In this lesson, we are going to examine the measures of central tendency, also known as the mean, the median, and the mode. Let's start with the mean. The mean is the sum of the data values divided by the number of data values in the set. The mean is used when no numbers in the set are significantly different. Let's take a look at an example where we calculate the mean. So here's a data set, and in this data set we have the numbers 1, 2, 3, 4, 4, 9, and 15. To begin calculating the mean, we need to find the sum of these numbers. Remember, the sum is the answer when we add, so we need to add all these numbers together. So we can do this using some mental math, or we can use the calculator. Let's try some mental math first. 1 plus 2 is 3, plus 3 is 6, 6 plus 4 make 10, plus 4 is 14, plus 9 is 23, plus 15 makes 38. We can also use the calculator if you just want to double check that. So 1 plus 2 plus 3 plus 4 plus 4 plus 9 plus 15 equals 38. Excellent, good mental math. So 38, now that we have our sum, we need to divide by the total number of data values in this set. So in this set we have 1, 2, 3, 4, 5, 6, 7 data values. So 38 we're going to divide by 7. So here we have 38, and let's divide this by 7, and we get a decimal. Don't let this decimal scare you though, because we are going to round because we only want one whole number. So 38 divided by 7 equals 5.428 and so on, but we're going to round to the nearest whole number. So we'll take a look at the 4, it's less than 5, so we're going to say this equals 5. So our mean for this data set equals 5. And there we go. That is how you find the mean. It's as easy as adding the data values and dividing by the total number of data values or values in the set. Let's continue our examination of central tendency by calculating the median. The median is the middle number when the numbers are arranged in order from least to greatest or from greatest to least. It does not matter whether our numbers are arranged from least to greatest or greatest to least, as long as they are arranged in order. Now, when there is an odd number of values in the data set, then the median is easy to find because there's only going to be one number in the middle. However, when there is an even number of values in the data set, then the median is going to be the mean of the two middle values. If that sounds a bit confusing right now, we're going to do an example in just a moment, and that should clarify things for you. Unlike the mean, the median is used when the numbers in the data set are significantly different, and we'll talk about what significantly different numbers mean in just a moment. Let's take a look at this example where we calculate the median. Here we have numbers in a data set: 24, 50, 60, 64, 67, 71, 73, 75, 82, 98, and 99. First of all, in this data set, when we look at the number 24, it's quite different than the rest of these numbers. So we could say 24 is a number that is significantly different. So the median is a good measure of central tendency to use for this data set. What we need to do is, first of all, arrange the numbers in order from least to greatest, which they already are. So we're going to find the middle number. There are 11 numbers in this data set, so the middle number is going to be the sixth number from the end. 1, 2, 3, 4, 5, 6. So 71 is the middle number in this data set. And we can check that by looking below and above 71. So we have 1, 2, 3, 4, 5 numbers below, and 1, 2, 3, 4, 5 numbers above. So in this case, the median equals 71. Now, if I do something like this and reveal a new number, all of a sudden we have a slightly larger set in this data set, a larger number of values in this data set. Now we have 12, not 11. So we're going to have two numbers that are in the middle. And in this case, 67 and 71 are the two numbers in the middle. And we can double check by seeing that there are 1, 2, 3, 4, 5 below 67 and 1, 2, 3, 4, 5 above 71. So these two numbers are in the middle. So what we need to do is calculate the mean of these two values. Remember, the mean is the sum of these two. So we're going to start by adding these two numbers together. So 67 plus 71 equals 138. We'll spit that number out here. So say 138. Next thing we need to do is divide by the total number of values in the data set. And in this case, we have two numbers, 67 and 71. So we're going to divide by 2. So over here we have 138 divided by 2 equals 69. So in this second example, our median is 69. So in the blue example, median equals 69. Let's continue by calculating the mode. Now let's take a look at the mode. The mode is the number or numbers that occurs most often in a data set. There may be no mode, or there may be more than one mode. Let's take a look at an example. In this example, we have the numbers 2, 2, 4, 5, 7, 8, 10, and 11. Now it's pretty clear to see that the number 2 appears twice and all the other numbers appear once. So in this example, we're going to say that the mode equals 2. If we had a different number set though, let's say we had 2, 2, 4, 4, 5, 5, 7, 8, 10, and 11. In this case, we have 2 2s, 2 4s, and 2 5s, while 7, 8, 10, and 11 all appear once. So in this case, we have more than one mode. So we're going to say the mode equals 2, 4, and 5. So we have 3 modes in this second data set. So 2, 4, and 5 are all modes in this data set. If we look at one more example, let's say we have 2, 4, 5, 7, 8, 10, and 11. In this example, all the numbers only appear once, so we don't have any mode. So no mode when we only have numbers appearing once. One more thing to consider is outliers. Outliers is any number in a data set that is significantly different from the other numbers. Now we already saw some numbers that are significantly different when we looked at the median. Let's take a look at another example of numbers where we have an outlier. Let's say we have a data set with 1, 91, 92, 93, 94, 95, 96, 97, 98, and 99. In this example, we can see that we have one number that is significantly different, and that is the number 1. So 1 is quite different than these numbers here. So 1, we would say, is an outlier. It is significantly different. We're now going to put all these ideas together in one final example. Sometimes when you're given a data set, all the numbers are out of order. Just like this data set, where we have 32 numbers, but they're not arranged in any order from least to greatest or greatest to least. So in this case, we're going to use a stem and leaf plot to help us organize these numbers so that we can then calculate the mean, the median, and the mode. So to do this, you're going to take your ruler and draw a stem and leaf plot. So we're going to draw one vertical line and a horizontal line. And we'll label this as well. So we're going to label this half the stem, and this is the leaf over here. Now what we're going to do is organize these numbers from least to greatest and put them in the stem and leaf plot. So we're going to take a look at the data set and try to find the lowest number. So here we have some numbers in the 40s, we have a 48, and here we have a 42. So this is the lowest number in the data set, and this is our starting point. So to do this, we're going to take the first digit in this number, in this case the 4, and write that in the stem. So 4 is our stem, and the 2 is the leaf. So this is how we write 42 in a stem and leaf plot. So it's read as 42. And we're going to cross that out so we don't write it in again after we've finished with it. So here we also have 48. Now instead of writing another 4 in the stem and the 8 in the leaf down here, we're going to use the same stem and write the 8 as another leaf coming off of this stem. So 48, we're going to write the 8 over here, and we'll cross this out. So now this is read as 48. So we have 42 and 48. Through the magic of video editing, you can see that I have completed the stem and leaf plot and crossed out all the numbers. So what we're going to do now is find the mean, the median, and the mode. Now to find the median, we didn't have to do much with the stem and leaf plot. We still have to add up all these numbers and find the sum. And to save us a little bit of time, I have done that already. So the sum of the numbers in this data set is 2,420. So spit that out here. And as we know from the start of the video, we need to divide this number by the total number of values in the data set, and that is 32. So if we divide 2,420 divide by 32, that equals 75.625, so spit this out, and not to worry about the decimal because we are going to round to the nearest whole number. So to do that, we'll look at these numbers here and we'll round up to 76. So in this case, the mean equals 76. Now here's where the stem and leaf plot comes in really handy when we find the median. The median, as we know, is the middle number. Now in this data set there are 32 numbers, so the median is going to be the middle 2 numbers. So if we count the 16th and 17th numbers in the data set, those will be the middle 2 numbers. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, and 17 are right here. You'll notice when I counted, I started at the start and counted forwards, starting here again and going across. I never counted backwards. You don't want to count backwards because you don't want to miscount or misrepresent your numbers in your data set. So here we have a median. For us, it's lucky we have 79 and 79. So in this case, the median is going to be equal to 79. We do not have to go through and find the mean of these two numbers because the mean of 79 and 79 is going to still be 79. Finally, to find the mode, we look at the numbers that appear most often. So we have a couple 62s and a couple 63s. However, if we look a bit further, we see we have 3 79s and we have 3 84s. So in this case, we have two modes. So our mode equals 79 and 84. As always, you can download these slides from our class website and put them in your binder. Thanks for watching.